Okay, so welcome everyone to this session. Thank you for joining us. My name is Herzog. I'm a political philosopher and co-lead of the GYA working group Trust in Young Scientists, and we've co-organized this panel. This panel is about trust in science through science communication, which of course immediately raises a couple of questions. Who should trust scientists? Is it about politicians or other decision makers, the general public? In the corona crisis, we saw that there were many appeals to behave in certain ways, which were, of course, about everyone behaving in a certain way, not just a few politicians. So you need everyone to trust in these kinds of cases. But then also, what is trust, actually? In philosophy, my field, there's a lot of discussion about how trust is more than reliance. It has a moral dimension and it creates responsibilities on the part of those who are being trusted. And trust makes us vulnerable in a sense because it can be abused. In psychology, research distinguishes between two dimensions of trust, competence and warmth. And according to some studies, scientists are perceived as very competent, but not necessarily as so warm. So that's an interesting empirical observation there. And then, of course, science communication. How can it contribute to building the right kind of trust in science? And what are promising strategies? What might also be pitfalls in the current climate when scientists communicate with the broader public? So just to get you into the mood for the topic, I'd like to ask just a few questions, which I'll throw at everyone in the audience. And if you like, you can briefly answer in the chat or just think about it. The first one is, are you a consumer of science communication? And if so, what do you like or not like about it? Have you ever tried science communication yourself? Have you done so in an area where trust in science has been weakened and where things have been controversial in the past, such as vaccine hesitancy or climate change issues? And last question for everyone to think about, can you think of examples of scientists successfully building trust through science communication? And what can we learn from them, maybe? So this is just to get you a bit to think about these topics. And I'm very happy that we have three great speakers here today. I'll introduce them very briefly because they have such impressive CVs that it would take up the whole session if I try to cover everything. We have with us Marcia Barbosa, who is professor of physics at the Federal University of Rio Grande do Sul in Brazil. Her research focuses on properties of water and complex fluids, and she's an advocate for women in physics and open science, and a member of the Brazilian Academy of Science and the World Academy of Sciences. And she's going to give the first presentation. The second presentation will be by Daniel Sarewitz, who's professor of science and society and co-director of the Consortium for Science, Policy and Outcomes at Arizona State University in the US. He is interested in relationships among knowledge, technology, uncertainty, disagreement, policy, and social outcomes. And he co-founded this consortium. And he's also an editor-in-chief of the journal Issues in Science and Technology. And the third speaker is Stephan Lewandowsky, who's professor of cognitive science at the University of Bristol in the UK. He is a cognitive scientist who was Australian professorial fellow from 2007 to 2012 and was awarded a Discovery Outstanding Researcher Award from the Australian Research Council in 2011. And quite recently, he was a lead author of a report for the European Union on the impact of the internet on democracy. So as you can see, three experts who are really very well versed in these topics and who will give us their input. So I'll leave the floor to Marcia first. Thank you so much, and over to you.
Thank you for inviting me. I am a physicist, so I see the world as divided in two bubbles. My bubble, my comfort zone in academic life, and the other people's bubble, in which they consume science. And I'm comfortable with that, but there is a problem with that model. And the problem was viewed not by the scientists many years ago during Barack Obama government by Randall Murrow, a cartoonist, in which he shows a university ground where a student come to the professor and start to talk about that nasty person that don't believe in science, don't trust science, say ridiculous things. And the professor said, who cares? You know, I am in my bubble. I am in my university where I know everything. Finally, after a long discussion, the students say, but this person, this ridiculous person, is a US senator. And at that moment, the scientists realized that there is a problem. Remember, I was not talking about Trump government. I was talking much before. And much before, people start to be uncomfortable because the power and the rich, the ones that can decide how much money we have in our labs, didn't believe in science. But you should also be worried about other people, not only the ones that give us directly the money, because the ones that elect these people are the responsible for us to receive the money. So the question is, have science its authority, the thing we need? We want science to have authority, recognized? And the answer, unfortunately, is no. And I can show you that we have a number of fields in which this is very clear. First, what I call the gateway drug to the unscience, that's climate change. Climate change is very easy for people to deny because it's too complicated. So people say, I don't believe in that. It will change my life. Then there is the vaccines. And finally, the flat earth. That even today, I have to explain to people why earth is not flat. Something that was from antique time. But why people don't think science have authority? And I go long before to Max Weber, in which he recognized three types of authority: the traditional, the old people, the kings, the people that have the old power, the legal, that's the law, and the charismatic. And I don't see science in any of those things because science is revolutionary, it's not traditional. And even though we call, Newton's law, have nothing to do with the legal law, because legal law go forward and go back. See some countries in which the law changed backwards, not talking about any issues like abortion that is going backwards in many countries today. And of course, scientists are not charismatic at all. So there is no authority in science, and that should scare the scientists because we hope to have the final word of everything. But okay, I am a physicist, so I challenge even Max Weber and say, why should we build an authority in science? How should look like this authority of science? And science should not be on faith, but on trust. And it's based in a very strange thing because it's based on evidence. It's based on a consensus that's not democratic. The consensus was a very private jury, that's the jury of the scientists. It takes a long time. So this year that we are seeing all the research about the pandemic going on like it would be a big brother science, people are even more scared because they are seeing how this consensus is built online with people struggling. So it's a battle in the mind of people between faith and trust. And you should trust science. So what's the difference between faith and trust? And I remember the time in which I go around visiting countries in Europe or visiting the United States, and I'm all the time lost. And I'm old enough to be visiting a time in which you didn't have GPS. So what I did, I stopped people in the corner and I asked for directions. And I have to have faith because I didn't know these people. So I had faith. But however, today I use the GPS. And in GPS, I have trust because it's based on science. But many people ask me, Marcia, why should I trust science? Why should I trust the authority of science? And I have many arguments, but today I'm just going to give you the one that I prefer most. That's the average lifetime of people over time. And you can see a jump when you start after the Industrial Revolution, when you have to start to have antibiotics, vaccine, more food, all that thing that allow me today to be alive, because if I would be living in Media Wage, probably I would be dead, is thanks to science. So when people say, why should I trust science? Say, how many medications you take a day? Do you have food, industrialized food? So all the things that make possible for me to be here is thanks to science. So we should trust science. But how do I communicate this information to the people? How I do this trusting science, trusting the authority of science, how I do that job. And the first thing you should do, and I'll say to my colleagues, the first thing you should do is to take our superpower scientists and use all our knowledge to talk about science. And the first place we should talk about science is between ourselves, because we trust our science. I'm a physicist, so I trust the physicists. However, even inside our campus, many times we don't trust the social sciences, don't trust the medical science, we don't trust the others. So we have to start to work at home, trusting the authority of people from all the fields and listen what they have to say. We live in campus, we don't obey, don't globally listen to each other. We are not using in our institutions innovation, active learning, sustainability, interdisciplinary, diversity, democracy. We don't trust, and you don't give any power, or we don't well evaluate people doing communication of science and even innovation in the administration. So we have to start at home. But now we have to communicate everywhere. And when I say everywhere, it's everywhere. And that's my basic roadmap when I want to talk about science. When I do my science, I start showing evidence at the level that people can understand. I show that trusting science makes the system more efficient. I have to do that at the level of the listening person. I don't have to come with the same talk to everybody. I have to be able to talk at the level of the knowledge of the other. What means equity? Equity of difference between regions, between knowledge, between beliefs. And for a starting point, I should start with empathy. Does not work to say you are wrong, you're stupid, you don't know anything. You have to bring the person, start with the little knowledge this person has and build from that. Starting with you are right in this point and build the trust from that point. So use evidence. Show that we need a system that's efficient, and science make the system more efficient. Bring the equity. Look to the diversity of the audience. And finally, if you don't have empathy, you're not going to do well the job. Thank you.
Thank you so much, Marcia. We'll give you a virtual round of applause. This is always a bit weird on Zoom, but thanks a lot for starting us off with this great talk. And I hand over now to Dan.
Thanks, Lisa, and thanks, Marcia, for those lovely comments. Let me put my screen share on here. 1 second. Let's see. Okay. Whoop, it says my screen sharing has failed. Hold on 1 second. Let me try again. Okay, I think it's going to work this time. Yes.
That looks good.
Okay.
Yeah, you're not
Beautiful.
full screen, but we see. Yeah. Thank you.
Okay, full screen now. Okay, all right. Sorry for the technical glitch. Marcia we're talking about trust in communicating science. Marcia talked about trust. I'm going to talk a bit about science and what we mean by science, because I think just as with the term trust, and Lisa's opening point about trust being a complicated concept, I think science is also a big, complicated, messy enterprise, and we perhaps do ourselves a disservice in using it in the singular as if we're always talking about the same thing. So I'm gonna introduce a little bit of social science theory here, and I'm gonna do it via just a couple of items that are reasonably familiar to everyone at this point. So here's a 100-year-old journal article offering some empirical evidence about a debate going on at the time. This was towards the end of the 1918 flu epidemic, and it's a debate about the efficacy of cotton face masks. So this is a debate that 100 years later is still ongoing and still very much in the public sphere as a result of the attention that we're all paying towards how to stay healthy under COVID. So that's one example from 100 years ago. But we see similar sorts of things going on now. On the front page of the New York Times, just last week, a story that I think would have been unimaginable on the front page of the New York Times, which has a particular political perspective, during the Trump administration, which is a serious treatment of the question of whether or not COVID might have had its origins in a laboratory in Wuhan, rather than simply through the natural processes of introducing the disease into populations via the consumption of wild meat. So this is a very complicated issue. In fact, if you read the article and what people are saying about this, it's likely we'll never have a final resolution. But the point is that during the Trump administration in my country, if President Trump had said, well, it probably came from a Chinese lab, we would have thought that that was ridiculous and it would have never made it onto the front page of the New York Times, except in a skeptical way. But now we're taking it more seriously. Of things of this order, here is a story that also was in a major newspaper on the front page next week about unidentified flying objects, because it turns out that there is now a legitimacy emerging around observations especially from pilots of aircraft, of things that they don't know how to interpret. And this is the sort of thing that's mostly been a joke. It's mostly been a sign of whether or not you're a rational person or not, whether you believe in such things. Now, whatever one wants to make about these complex phenomena, these observations, it's suddenly being taken seriously as a problem to think about in an analytical, careful, empirical way, rather than simply to write it off as something that only fools or charlatans or ignorant people would believe in. So the point I want to make just with these three examples is that there are issues in science at the intersection of the complexity of phenomena, of society, of politics, that are very different from the way we think about science and talk about it as a lab practice, as something that's highly controlled, as something where we can have a kind of a structured self-correcting process through peer review and so on, basically the sort of science that Marcia was describing. And I think a helpful way to understand from a kind of simple conceptual perspective what's going on around things like climate change and things like vaccine refusal, but lots of other phenomena as well, is the theoretical framework that Sylvia Funtowitz and Jerry Revets came up with actually 30 years ago now, but I think it's more valuable than ever. in a paper called Science in the Post-Normal World, in a journal called Futures. And what they do is they distinguish what they call normal science. And if you've read Thomas Kuhn's Structure of Scientific Revolutions, you'll know that normal science is just the sort of science we do every day, the kind of puzzle-solving, incremental, try to figure out what's going on within a particular paradigm of understanding, whether that's Newtonian physics or the field I come from, global tectonics in geology or evolutionary biology. That's normal science. But the sort of science that we're mostly talking about in this session has a very different character. There's often deep uncertainties. There are values that are under dispute, the values around what we ought to do. There are high stakes, that is to say, winners and losers. And we need to make decisions in the public sphere, not just decisions about what method we should use to try to test a certain hypothesis or to try to develop some valid understanding of a particular phenomenon. So what I want to emphasize is that in a very literal sense, post-normal science, we may call it physics, or we may call it atmospheric chemistry, or we may call it evolutionary biology, or toxicology, or whatever, but post-normal science is a very different thing from normal science. It's different because of these four constituent attributes, and it behaves differently. And the question of trust and post-normal science is an extremely complicated one that cannot be solved simply by being open about the science itself, by working with people to understand what we're doing, because it includes this inherently disputed set of factors, only one of which is really very directly addressable by the science, that is the uncertain facts. And even there, as the case of cloth masks show, that uncertainty may not be resolved even after a century. But disputed values, high stakes, and urgent decisions, those are the sorts of things that are really outside the domain of science, even if we're asking science to answer questions related to such issues. So this is where a lot of what concerns us now lies. And let me give you a concrete example of the difference between how one might think about trust in post-normal science in an effective way or an ineffective way. This is an overly busy slide, but I just am using it to show what I hope is a clear point about the differences in outcomes of two very similar processes. So on the right is a picture of a town in Sweden. On the left is a picture of the town in the United States. The town in Sweden is going to be the site of a nuclear waste repository. The town in the United States was supposed to be the site of a nuclear waste repository, but the problem is still being debated and it's still politically extremely controversial, and there's no solution in sight. What I just want to very briefly say is that the Swedish approach recognized, in a sense, the post-normalness of the problem, and they located the solution in democratic process. There was lots of participation of different towns, of citizens, of scientists working within local populations to build trust around process, not around particular facts. In the US, the site was chosen, and then the science was done to try to convince people that the site would be safe. So these are very, very different institutional approaches to science. In the US, it was treated as if nuclear waste storage, that is safely storing nuclear waste for 10,000 years or more, was a problem of normal science. In Sweden, it was understood after some initial failures in the US mode that actually the politics, the trust, the institutional structures needed to come first. Then the science could do its work. And that's a post-normal approach. I'm just going to say that the point I want to leave you with is that trust in science is therefore not so much a communication problem in the way we normally think about it, but an institutional design problem. These are three examples from the United States. I'm not going to go into them. I'm simply going to say that in particular cases where we see complex post-normal science leading to effective political action, what we see is good institutional designs. In the U.S. Geological Survey, this top instance where we assess oil and gas resources in the U.S., there is a toxic chemical organization called the Toxic Use Reduction Institute. There is a mode of providing advice for economic decisions at the national level called the Federal Reserve System of the United States. All of these are effective in using post-normal science because the institutions are designed in ways that are transparent, that are participatory, that accept uncertainties and value disputes as part of the scientific process. So that's a really just brief, very high level kind of superficial sketch of the main point that I want to leave you with is that as my late friend Steve Rayner would say, it's the institutions, stupid. That trust emerges from the way we interact at the intersections of science, policy, politics in a post-normal world. This argument is laid out in, I guess, exhausting detail in an article that Steve and I recently wrote in the Breakthrough Journal. The URL is very long, but you've got the title there, and you can find it by Googling if you'd like to. But again, the point I want to leave you with is that trust, in my view, is more important than is more important to be understood as a institutional phenomenon rather than a communication phenomenon. If we don't have the right institutions and institutional arrangements, all the communication in the world won't give us the trusting relationships that we're hoping for as we try to apply science to the solution of our difficult problems. Thanks very much.
Thank you very much, Daniel, for this thought-provoking talk here. And now I hand over again, after a round of applause, you all know the reaction buttons, to Stephan. Yes, thank you.
Okay, thanks for that. Well, it's fantastic to follow those two really interesting talks because they've set up a lot of the things that I also want to talk about. And I found myself to be in agreement with a lot of things that both Marcia and Dan have said. Now, to put this whole thing in context, I'm repeating what we all started out with, which is that the glue that is holding together the scientific enterprise and its influence on the public or its role in public debate is trust. Trust is a critical issue. And yes, I agree with Dan. Of course, trustworthiness is, among other things, the result of the institutions that are in place. And in fact, I would argue that the scientific enterprise, in a sense, has been designed to maximize trustworthiness through things like peer review and transparency and all those other measures we're now increasingly talking about, making data available, making science reproducible, making it replicable, using pre-registrations in research, and so on, et cetera, et cetera. I mean, all of these measures are seriously important. They contribute to the trustworthiness of science. But that's not the whole story, because the scientific enterprise, especially when it comes to post-normal science, is not operating in a vacuum. Sometimes, sooner or later, if you're a scientist, and it's surprisingly quickly how you can stumble into this, sooner or later, you'll say something that has political implications. And if the political implications or commercial implications are big enough, then all of a sudden you're going to be confronted with an environment in which, in addition to the public and policymakers and everything else, you also have a group of people who I call generically adversarial influencers, whose goal is, frankly, to undermine trust in science. And they do this by attacking scientists or science, and by trying to confuse the public. And so, yes, of course, we have to be trustworthy. We have to build institutions that are trustworthy, that are maximizing trust. But we can do that all we like if we're not also recognizing that there are other people out there who are acting precisely in the opposite direction for their own political purposes. And climate change is the crucible of that adversarial situation. This is a link to a report that I wrote with a couple of other people in the climate arena some years ago, documenting the history of how, in this case, the fossil fuel industry has deliberately misled the American public and, of course, the global public about climate change. And this isn't just, one instance. There's a whole history there of the tobacco industry doing the same thing, of industries doing this whenever their commercial interests are impinged, be it Teflon, asbestos, lead in petrol. I mean, whenever science is in conflict with profits, you got a problem. And how do we deal with that problem? Being trustworthy alone, I can assure you, is not enough. So I want to answer a couple of these, sketch out and then answer a couple of these questions. I mean, the first question to ask is, well, how do we know that influencers act in bad faith? Because I'm making this claim about these people out there pursuing their politics by effectively untrustworthy means. How do I know that? Well, there's a number of lines of evidence. There's a huge literature on this. What I find particularly striking is the presence of deception, having what I call two sets of books. We know that Exxon, specifically ExxonMobil, the research has been done there, they knew about climate change decades ago. They knew that it was real. They, in fact, based their exploration plans on that, anticipating the Arctic to melt so they can drill up there, and all that kind of stuff is well known. But at the same time, they spent a lot of money on people who then denied that there was a problem. So there was a public-facing denial accompanied by internal knowledge that there actually was a problem. Now, I find these two things difficult to reconcile under the umbrella of trustworthiness. I'm more likely to believe that they're engaging in deception for very obvious reasons, which is to protect their profits. Now, beyond that, we can also analyze the rhetoric, and irrespective of how much uncertainty there is about masks or about climate change or any other scientific issue, uncertainty doesn't give you license to be misleading or dishonest or incoherent or fraudulent in your interpretation of data. Now, how do we know that influence operatives can be misleading or dishonest or whatever? Well, the one avenue that I've explored together with colleagues in several papers is to just look at representative contrarian statements about climate change. We did this in the climate change arena primarily, and to then translate them into a different domain, to take out all the politics and all the preconceived notions, all the emotion, it all disappears if you go to a different domain, then present it to experts to adjudicate the veracity of those claims. Here's just one example of many such stimuli that we created. This is a statement taken verbatim from some climate denying blog. Our glaciers are growing, not shrinking. Almost all glaciers are now gaining mass. Well, we start out with that claim. We then convert that, in this instance, into population statistics, completely arbitrarily, into something where people probably have less of a preconceived notion. We anonymize the source. We take out whatever we can to disguise what we're talking about. So here's the translation of that statement about glaciers, which is then presented to experts, statisticians, and economists. We use two different groups of expertise in a blind test. So they're shown the data, and they're then asked, well, do these data confirm the statement we've just shown you? Or is it at odds with that? And incidentally, that graph here shows the mass balance of glaciers. And as you can see, most of the bars are to the left of zero. That means the glaciers are shrinking, and there's only a few on the right that are increasing. Now, if you ask experts whether or not the data confirm the claim or whether it's misleading, et cetera, then if you aggregate across the items in our experiment, you find very clearly, without any ambivalence really, that the contrarian statements are considered to be misleading and unsuitable for policy advice. That's the negative bar I'm showing you here. These are actual data from one experiment, in this case, statisticians. Whereas mainstream scientific statements, that is those that are made in the IPCC reports and so on, are endorsed by the experts, not knowing that this was all about climate change. And we asked them afterwards if they knew, and they said, no, we had no idea. And we've done this several times over. And so to me, that is evidence of people who are not acting in good faith, or maybe just don't know what they're doing. Either way, uncertainty or not, post-normal science or not, they are not acting in the way that we would expect trustworthy operators to act. Now, this turns out to have consequences. We can trace the consequences as well through research, either at the level of individuals or at the level of societies overall. At the level of individuals, we can show that exposure to misleading statistics or misleading statements is reducing the public's acceptance of well-established scientific finding. And in fact, it is easier to do that than it is to provide material that convinces people of the reality of climate change. It's much easier to undermine trust than it is to build trust. And there's plenty of other evidence at the level of society. It's very obvious that these disinformation campaigns are having a detrimental effect on the political evolution of climate mitigation. So where does that leave us? Well, as I said before, of course, scientists have to be trustworthy. Absolutely, no question about it. But there's another aspect to this, and that is that the public has the right to be protected against being misinformed. The public has the right to be accurately informed about the risks it is facing. If that risk is being denied by political operators, then I don't think scientists should just say, okay, all I'm going to do is be trustworthy. Yeah, that's great. That's a great start. But it doesn't follow from that you have to accommodate bad faith actors as equal partners in some sort of a conversation. So, to my mind, to really build trust with the public, part of the problem of science communication is to define the boundary between, constructive involvement, post-normal discussions, getting the public on board, co-producing knowledge. Wonderful, let's do all that. But there is a boundary between that and misleading, politically or commercially motivated anti-scientific activities. And we cannot ignore that simply because we want to be trustworthy. We have to recognize there are some people who are not interested in trustworthy science. And I'll stop sharing there.
Thank you so much, Stephan, for this look at the darker side of the public interest in science and some agents who might have other motives. We'll open the floor to your questions and comments very soon. But before that, I would like to give the panelists the opportunity to react to each other, either with comments or questions. I saw from your faces that there might not always have been 100% agreement. So I would like to hear what you thought about each other's talks, or maybe ask more questions. And I would like to first give the floor again to Marcia.
Okay, I have a question to Stephan. It's, how do you react to this person, to the organizations and to this person that have bad intentions? You understand that if you're angry and you have a public in front of you, I don't think that will work. So what do I do?
Absolutely. And yeah, no, I totally agree with you. And everything you said earlier about, having empathy and understanding what's going on is very important. Well, what we know from the literature, from research, is that the best way to deal with adversarial actors is to preemptively inoculate the public against them. So there's a whole research program by colleagues of mine and myself called Inoculation, where we show over and over again that you can actually tell the public ahead of time, oh, by the way, if somebody comes and is saying X, Y, Z, and that's incoherent, well, then be careful, because it's very unlikely for somebody who's incoherent to be correct. For example, if somebody says, oh, don't worry about global warming because it's been cooling for the last 18 years. And then 30 seconds later, they say, oh, no, you cannot measure global temperature at all, right? Well, wait a minute. How do you know it's cooling if you can't measure the temperature? This is incoherent. Now, if you teach people to detect that kind of incoherent argumentation, which is extremely common in climate denial, I mean, we've got a list of 250 or whatever incoherent arguments that we've compiled. If you tell the public that, then they become demonstrably more alert to being misled. So that's how I would answer that. You expose the techniques that are misleading, and then people can make up their own judgment. Say, oh, okay, yeah, that is incoherent. Maybe I shouldn't believe it quite as much.
If I mind, Daniel, help me with that. If I got right, you put a lot of belief in democracy, because you say the institution, they have to build this process. How can I construct that if our own institutions, the universities, are very fragile in this issue of democracy?
You're still mute. Yeah.
Yeah, I'm not quite sure I understand the question, Marcia. It's about...
It's like when you give the example, you give you about Switzerland, you say that you have this huge discussion to make a decision, meaning that decision was a global, and that's for me resemble a global democracy. However, let's say democracy is a good thing to make decisions. However, we are designed in our university institutions as a top-down institutions. And how can we support such a democratic thing when in our own everyday life, we live in this such an autocratic system? That's how I can balance that.
That's a really great and really interesting question. I mean, one thing to say is that this is true in some institutions in the US, and I know it's true in some institutions in the UK, but actually there is significant cultural change going on in certain fields, in certain institutions, in terms of opening up the way science is done, so that, in fact, many of the kind of attributes that you put on one of your slides about what it takes to build trust, those will not emerge easily from a hierarchical academic approach. They emerge from understanding who you're working with and who your constituents are. So I think there are certainly trends pushing against what you're what you're saying is the standard culture of academia. For example, the role of disease groups and health advocates in the public health field. A lot going on with communities that are not happy with environmental monitoring technologies and are taking things into their own hands, are finding scientists who are working with them. The key might be funding agencies, because scientists will do what they're funded to do, and if they're funded to engage in a more kind of co-produced knowledge production context, they'll do it. There are some great examples of that in a number of our federal agencies. So it's an institutional change problem. That being said, there's also, of course, an inherent tension here, because good science does require the autonomy of a scientist working without political influence to the best of their ability to come up with results that are reliable. So on the one hand, you do have to be able to maintain some of the prerogatives of science as an autonomous activity, even as, especially in this post-normal realm that I'm emphasizing, you find ways to build institutional mechanisms that allow kind of a diffusivity. So I think that the changes are going on. They're slow. I don't think they're fast enough to catch up with some of the stresses that we're having to deal with. And I guess maybe the point is I'm agreeing with you about academic institutions, and they need to change. And I think sometimes they are, but slowly. Does that address your question?
Thank you. Yes, yes. Thank you.
Dan or Stephan, do you also want to react to each other? If not, I have a question for all three of you.
Ask your questions, unless Stephan has something to say.
Well, I mean, we are already moving in this direction. This issue of academia and how it is organized, this relates directly to this issue of trustworthiness. We don't want people to trust badly organized fields that have all kinds of internal problems, and we are all aware of dysfunctional incentives in science and so on. And even the consensus thing doesn't always cut the ice. I mean, I studied economics before the big financial crisis, and that was a field that was really misguided as a field, and it was the crazy mavericks that got some things right. Whereas in most other fields, we would usually say, oh, go for the majority. There are a few crazy mavericks, don't listen to them, listen to what most scientists say. But there are exceptions to that rule. And so what I'd like to ask you is what, and Dan was already going in that direction, how can we build academic institutions and also academic culture in a way such that it deserves to be trusted by the general public and by policymakers and so on?
I'm happy to talk, but I feel like I just did, so perhaps
maybe Stephan also looked like maybe we can go the other way around. Stephan and then Dan and then Marcia.
Okay. Yeah, I mean, I think it's a very good question, and of course we have to do that. As I said, to me, one of the key things is to be transparent. That is to and reproducible, to make all materials available for others to be able to reproduce your statistical analyses, for example, to make data available, which I think there has been a revolution in that, and certainly, well, during the last 10 years, I would argue that, yeah, it's been revolutionary, the extent to which things have become more transparent and reproducible, in large part because of the emergence of technology that enables that. I mean, it's much easier now to share your data on platforms like GitHub. There's a lot of technology that insists in that. So we definitely have to do that. We also, I totally agree with Dan, by the way, on this democratization and co-production of knowledge. I think it's extremely important. I'm not against that at all. But the problem is, as Dan said, you can't really have a vote on the value of pi. Okay, I mean, pi is a number that's determined, it is, and there's no debate. And you can't democratize facts. You can democratize a lot of decisions about what to do, but there are some fundamental facts you can't democratize, such as the value of pi. And that's a tension that I don't think anybody has resolved quite yet. But maybe Dan has, I don't know.
Well, what I would say that saying you can't democratize the value of pi is actually not really addressing what the problem is, Stephan, because you can't democratize that, but there are other things you can democratize. And so this really gets to the post-normal versus normal science perspective. So a standard thing that scientists will do to make fun of anyone who talks about democratizing science is they'll say, well, do you want to vote on Newton's laws? No, we don't want to vote on Newton's laws. But actually, scientists vote on things all the time. For example, we have panels in the FDA where scientists vote about whether or not a particular food additive should be treated as carcinogenic. So there are things where the uncertainties are such that a set of values and beliefs and different types of expertise will lead to different conclusions depending on who's doing the talking and who's doing the arguing. So actually there are things we vote on, but more to the point, in this mix of values and urgency and uncertainty that's so typical of so many of these issues. If we don't do it democratically, we'll do it non-democratically, but we're not going to do it scientifically in the way that we think of as traditional science, because these are not purely scientific issues. Now, I want to say, just as Stephan went out of his way to say he doesn't think I'm completely wrong about things, of course there are malign actors, and they are a big problem, and social media has made that much worse, and this is something we should not be naive about. But I do think that the problem of defining the boundary between constructive critique and bad faith influencers, which Stephan put out there as an important challenge, I agree it would be great if we could do that, but I think it's really difficult in many cases. Yes, you can find the extreme mischief makers, the people who are only motivated by profit, but I don't actually think that's the main part of the challenge that we're dealing with. I think the main part of the challenge that we're dealing with is that many of these issues actually involve uncertainty and values and disagreement, and science is only part of the problem. And if we say trust the scientists, then the question is, which science shall we trust, which scientists shall we trust, and how do we move forward there? And I think that doesn't really advance the argument. So not disagreeing that malign actors are a problem, serious problem, but I don't actually think they're the essence of what we need to address here. It is something we certainly cannot neglect.
Marcia?
Yes, I just want to add that the way the things are being discussed looks like we are talking about law. You know, the law, when it's built, is built by a democratic way. And I think we have to put an ingredient that is very distinct from law. In the law, you can go backwards. And I hope the scientific seed is put in this democratic debate in a way that today we don't make a decision that tomorrow you're going to make a decision that go against science, like the law can do. You know, if you go to some countries, you're going to see that something that today it's illegal, yesterday was legal, and the today decision is bad because it's misogynic, because it's a fact, it's a bad law. So law can go backwards. And I hope the way we democratize the discussion of science, today we have some uncertainties that tomorrow will be resolved, because science is resolving the uncertainties as it goes by. And tomorrow we're going to vote again, and the decision you being compact with this decrease in the uncertainty and not the other way around. And at that level, it's this battle between, you know, the economic or the political interests have to be won by the scientific knowledge. That's the third step. We have political, we have this economic, and I have the science. And it is a battle that have to be playing in a democratic ground. But I hope during the time, as time goes by, when we solve the issue, because I trust science, I know that we have uncertainties today that will be solved tomorrow. And tomorrow when you vote again, you vote with less interest and with more knowledge. And that is different from the law that resolves everyday life.
Thank you. Stephan, you had your hand up. You probably wanted to react to one of these.
Well, I think, yeah, actually to both of you, and the issue of uncertainty and you know, what the implications are of that. I think that's you know, an incredibly fascinating issue. And one of the things, two things are true, or at least, there is scientific uncertainty about a lot of things, number one. Number two, however, uncertainty has been used as an argumentation method in order to undermine what is actually robust scientific knowledge. For example, the tobacco industry has gone on about uncertainty for decades, you know, and now one of the major aspects of climate denial is to appeal to uncertainty and to say, oh, it's so uncertain, we have no idea what's going to happen in the future, so why should we worry about it? And I think that to my mind is a key issue to resolve, because and this goes to the post-normal thing and what Daniel is saying, and that's, I guess, where I'm becoming a little critical of Dan finally. Uncertainty is no barrier to action. Quite on the contrary, in the climate change context, the greater the uncertainty, the greater the impetus to act because of something. I mean, I don't have time to explain it now, but it's got something to do with Jensen's inequality in convex functions, meaning that the greater the uncertainty is, if that increases the tail risk, then you have a greater impetus to act than if the uncertainty is smaller. There's a bunch of papers on this out there. I'm happy to share them with you. But in a nutshell, uncertainty, appealing to uncertainty to say, oh, let's not do anything, is a serious problem, because very often the opposite is true. The fact that there is uncertainty should make us worry more. I'm much more worried about climate change because of the uncertainty. If I knew exactly what was going to happen, oh, great, we just evacuate Venice or whatever, rebuild it somewhere else, and the problem is solved. Yeah, but we don't know what's going to happen. That's the problem. So appealing to uncertainty, to my mind, is a very double-edged thing. And to then say, oh, because it's so uncertain, we can't rely on the science. I think, if that's what you were saying, maybe I'm putting words in your mouth, Dan, but if that's what you're saying, I think that's very problematic, because that's not always true. Quite on the contrary, the uncertainty is what should make us act.
I didn't say that. I don't believe it. The point I'm making is that uncertainty, you say, uncertainty is no reason not to act. That's obviously true. In fact, governments make huge decisions under uncertainties that are infinitely greater than the uncertainties around climate change to do things about, say, social policies. So uncertainty has nothing to do with whether we act or not. What uncertainty does is it creates space for value disagreements about what is to be done. So let's set aside people who deny climate change, okay? And we can even say that many of them, if not most of them, are malign actors, or at least they're under the influence of malign actors. The question of what to do is still very, very difficult and very, very complicated. Yes. So my point isn't that uncertainty is a reason not to act. Uncertainty often is exactly a reason to act, but the question is, how shall we act? And that's what's very difficult to confront. And so the examples of the institutions that I was providing were those that I think are good models for how you act in good faith when there is uncertainty and disagreement, but you still must act. And that's the challenge here, I think.
Yes, so I'm not disagreeing with you at all on that, no.
Well, actually, then let's take the opportunity of a point of agreement to insert some questions. And I've seen that in the chat, people have already started asking questions. The first one comes from Abhijit. Are you in a position to ask the question in person, or should I read it out? Well, I'll read it out then, but for others, you're here, great, then please ask it yourself.
So my question was that, we have seen that some Nobel laureate, spread some misinformation. Now, when I am dealing with common people, how can I tell them that this ex-scientist is more trustworthy than this Nobel laureate? Or how do I kind of, when something comes from a celebrity scientist, it is difficult to, in public perception, it is difficult to challenge. Thank you.
Who wants to take this one? Stephan?
Well, I'm sorry, did someone else going to say something?
Dan, I'm easy. I mean, you go.
Right, it's a difference between an Aussie and an American. We're never easy, right? So, I'd simply say that's a really tough problem, and it's at the center of my concerns here, which is a celebrity scientist. That's a person with credentials who's supposed to represent the reasons that we trust science. They have that status, and that's why we trust them. I'll simply say that there's no easy to answer, but this gets to my point about how we need to focus on institutions. Now, once you're in a position where you have debating scientists at a high level, and especially celebrity science, it is very, very difficult. And so, Stephan, I think you're going to save me here and say something more constructive.
I mean, first of all, I agree, but I wouldn't quite throw up my hands in despair, because one of the things about your Nobel Prize winning scientist who's sprouting misinformation is probably that they're talking about an issue they have no clue about anyway. Okay. Now, I know that Nobel Prize winner are I probably shouldn't say this, but I'll say it anyway. They really scare the hell out of me, because having gotten a Nobel Prize, unfortunately, quite a few of them think they can speak on issues that have nothing to do with their discipline. And if you look at the history of Nobel Prize winners, wow, there's a lot of stuff like that. So my first test would be, does this guy actually talk about his own field or something else? If they're talking about health when their Nobel Prize is in physics, I would be very skeptical. I think that's clue number one. Now, the second clue is, I think it was Lisa who said that a consensus isn't always indicative. I mean, I agree with that. You can probably come up with cases where the scientific consensus turned out to be false, although it's actually surprisingly difficult to find these cases. In most instances, however, I think a scientific consensus is the best available indicator of scientific knowledge that we have. And if some Nobel Prize winner in physics talks about tobacco not being dangerous in contravention of that consensus, then I think the chance of that person being right is extremely low. So I think we do have tools. It's not quite impossible, even for the public, to discern likelihood of value in people's statements.
Marcia, do you want to add something?
Yes, we are living that. It's at the moment the Congress of Brazil is discussing the one medication for COVID, and there is some celebrity medical doctors going there and say, well, it's good, but then there are another that go, and in that point, there is no empathy, I may say. The ones that are proving with reference that this medication doesn't work, they are beating hard, because they are going to show to the public, this person doesn't understand. There's a public debate. People are, unfortunately, I'm not following at this moment online, but people are fully following the debate. And at that point, it's important to have reference. So that's the point where it's bit, show me your reference, and they show some reference, and people say, look to the type of journal and look to the discussion in which is like a cowboy thing. Show me your guns, I'm showing your guns, and who shoots with more bullets, better bullets, and more consensus. So sometimes we have to be rushed. And in that point, you have to be rushed. You have to say, you're a physicist, you're not a medical doctor. You should not say, anything about that.
Yeah, thank you. In media ethics, there's a line saying, the audience gets the media they deserve. And there's probably something a bit like this going on here as well. If the public and also journalists are not at all critical, that of course facilitates these kinds of problems. And indeed, I had at least one question, maybe two. Anindita, do you want to speak? Can you speak, or do you want me to raise it?
Sure.
You're here.
The first question was kind of a response to what Daniel said about funding and science. So you said that, scientists will do the research that gets funded. And then my point is that if funders dictate the majority of science that's being done, then how do we help to maintain trust in science? Will trust in science not eventually come down if funders are allowed to dictate the science that is done? And I will just, ask the other question, someone who might want to answer this. I'll, just talk about it. So, in the previous panel that we were talking about science advice, the point came up that sometimes scientists change their opinion or based on recent findings, and that's why people don't trust science as much as they do, say, religion or some belief system, which seems to be consistent and constant, whereas scientific advice can keep changing, especially in the times of COVID. With new research, people are, for example, the gap between 2 vaccine doses that has been changing, at least in India. And that's based on science advice. And then the question was that if science can change so often, how will people trust science? And this is my question here is, as scientists, how do we communicate to the general audience so that they can take this change in scientific advice in a positive sense rather than a negative one?
Who wants to start on this one?
Well, I can just quickly address the specific question about funders. First, I just say, again, we're using the word science in a very indiscriminate way, and that makes it difficult for us to actually have the conversation that we want to have, because all science isn't the same. But in terms of your specific point about if the funders dictate the science, my point wasn't that funders should tell scientists what to do, but funders can do things around incentives. For example, they can say that if a university, they can encourage universities to reward scientists who work with communities, for example, or they can have programs that fund scientists to work with communities to develop research agendas around, say, climate adaptation. So it's simply around incentivizing different ways to organize science, certainly not around telling scientists what to do, although obviously there's lots of funding that is aimed at particular types of science. There's no way around that. But I did not want to suggest, and spoke too quickly if I did, that we ought to let funders dictate the science that gets done.
Marcia, you wanted to react?
Just add one point on that. There's some experience in which the funders say you get X if you do whatever you propose to do, but we give you X plus something if you also do some science communication, or you have a more diverse group in your research group, or if you do something, you get a plus. And it's unbelievable how people want this money, so they end up doing the plus, whatever the plus is, whatever they believe about or the plus or not. But now coming back to the second point, how we say to the people, the scientists keep changing their mind. Today they say wear a mask. Tomorrow they say you have to use this more strict mask. How I work, and I always say that it's a consensus, and to reach a consensus, you need the debate. But different, and I always make this point very clearly, different from the government law, the consensus don't go backward. We are not going to say tomorrow that the earth is flat. You're not going to say that the vaccine don't work. You're not going to say that, because that's well-established thing. But because we are living this big brother science at the moment, people are seeing the consensus being built up. And this takes time. And people have to understand that we are going to learn something today and you'll be a little bit different tomorrow, but not going to be something, back. We are not going to say that there is no problem in climate. You're not going to say that. We are going to narrow and narrow and narrow the problem. And we have to get used to that uncertainty. Remember, women didn't drive in my country 50 years ago. They are not allowed to drive, and today they can drive. I assure you, science is not going to say in 50 years from now that they should not drive again. Okay, so there is going forward, but I'm not sure if my government is not going to say that a year from now. So it's go forward in science and not backwards.
Can I add something there in the context? Yeah, thanks. In the context of COVID-19 vaccinations, as you all know, there's been some sort of discovery recently of side effects to the AstraZeneca vaccine, and a colleague of mine from Denmark has just released a study where they looked at the effects of the suspension of the AstraZeneca vaccine on people's trust in that vaccine, and also generally in the health system and other vaccines. And to make a long story short, the way it appears to have played out is that the suspension of the AstraZeneca vaccine in some European countries has reduced trust in that particular vaccine. But the other vaccines, trust in the Pfizer and Moderna vaccines, has actually increased. Now, I'm not saying that was because they suspended the AstraZeneca vaccine, but what it points to is what my Danish colleague Michael Peterson has found. What it points to is that having trust in public institutions is what is absolutely crucial for people to be willing to take vaccines. And that's, I think, exactly also what Dan has been saying. We got to have these trustworthy institutions. If people trust the public health system, then they'll be less vaccine hesitant. And sometimes to maintain that trust implies having to take a short-term hit. You know, you have to sacrifice people's trust in one vaccine, lose that battle to win the war, which is trust overall. And I think the public has been surprisingly good at that in Europe, in my opinion, looking at the public opinion data with the vaccines.
Thank you. If you're all fine with it, I would like to collect a few questions and then you can pick the ones you'd like to react to, just to get a few more on the table. So we had Jim. Jim, are you available?
Hi, sure. Yeah, I guess this is to Daniel and kind of a reaction to Stephan speaking about inoculating against these malign voices. Some years ago in the United States, there existed, and for many years, something called the Fairness Doctrine, whereby broadcasters were and publishers and so forth were required to act in the public interest. And then in the early 90s, I think it was, that Fairness Doctrine was done away with. Do you think that had any sort of impact on amplifying these sort of malign voices that you were mentioning before?
Thank you. Then Eschar, are you Eschar? Sorry for probably mispronouncing. Yes, you're here.
No problem. Can you hear me? Thanks. My question is for Daniel, I think. So I guess we're all supportive of institutions that would follow the general principles of transparency, being participatory, accepting of disputes, etc. But my issue is, how do we move beyond that and actually create these institutions that resiliently function like this? One of the problems is you have a few influential people within it, or one bad faith actor or a director that comes in for 5 years that can really mess up the whole thing very quickly. So I'm trying to get some agency as an early mid-career researcher in the community. What are steps 1, 2, and 3 that allow people like us that we can get behind to actually make this happen on a larger, broad scale level, and one that's more resilient and stable? Thanks.
Thank you. Then I saw a couple of questions / comments that were related to Amandita's question. So please signal again if these were not yet answered. Ansia had her hand up. Is that still an open question?
Actually, I just wanted to ask a really stupid question as a scientist. I just wanted to know that where these concepts of the not trusting in science comes from. Because is there any example that's showing that when we trust to the science, big disasters happens that cause the people not trust in science anymore? But because it's a big deal and question, because we show the tables, the statistics, experimental results, and all these things, and the publics don't accept the idea that has experimental concepts and also statistics. So that comes to my mind, that why is the case if the trust in science somewhere in the history of the science caused something really disastrous that people don't trust it anymore? And or it's just a misunderstanding because of the media and all these things.
Thank you. And then Luciana had a last question, and then we'll have a round of answers.
Thank you. Well, at some point it's related to Anshi's comment. My question was about how can we build trust with people that definitely doesn't believe in science at all. So when we try to convince someone to believe in or to trust in science, we are assuming that the people value scientific knowledge as a critical resource that legitimates somehow our opinion. What happened when this basic when this basic fact is not in the other person in other. Thank you.
Thank you all. So we have great questions on the table. Who wants to go first, have their pick? Maybe we do the same order as in the beginning, Marcia.
Okay, I want to bring when it was a disaster not to believe in science. So now it's a disaster not to believe in science because there are people that are refusing to be vaccinated. So this is a disaster. It's a disaster when we had an increase in diseases in which people, we already have measles. We had an increase in some places. It was a disaster when I went to a meeting one time and a scientist said, I'm not vaccinating my kids. This is a disaster because this is gone and it should be gone and people should be vaccinated. At some point in the Brazil history, Carlos Chagas found that a certain mosquito generates a disease and he wants all the water, accumulating water will be cleaned from the houses, and people didn't want to do that. And people were sick because they didn't believe in what Chagas was saying. So every time we refuse a certain knowledge that will help our lives, it is a disaster. So trust in science, it is important. In the past, we rely on the fact that governments, kings, and people important that make the decisions would trust science. But now that we have democracy, that's not enough. We need that everybody would trust science. Otherwise, any health policy will be very difficult to be implemented. Very difficult. Even if you have the means, people will refuse. So that's when it's a disaster not have trust in science.
I'm not sure whether Ansia meant the question in that way. What I heard, but please correct me if I'm wrong, was that there might have been cases in history where it actually turned out to be bad for people because they trusted misguided science, and that led to mistrust. And
but that's the misguided. You understand that we could, at the moment,
Sorry, I just wanted to give one famous example here where something like that has happened, though it was arguably more a moral failure than a scientific failure. So there was a famous experiment that scientists did on Black US Americans in Tuskegee, where I don't remember all the details, but they didn't give them the right medication and used them basically as guinea pigs in a very racist kind of attitude. And that has done huge damage to trust in science in the US Black communities. At least that's what sociologists of science have long argued. So it's not like there have not ever been any cases where science has also contributed to undermining trust. So maybe that would be one element here. Sorry, back to you, Marcia.
Yeah, one example is that during the COVID, some scientists in Brazil, they claim a certain drug that is used against one usual disease in Brazil could be used to cure COVID. And people are taking tons of this drug, and the government actually put a lot of money to buy and give free this drug. However, this drug have huge side effects. And now our hospitals are starting to have, in addition to COVID, heart problems because people are taking this medication that's given almost for free from the government, because some scientists in Brazil did this research and they claim this medication would work.
I have a question.
Sorry, let's give the floor to Dan next.
Okay, thanks. These are all great questions. I'm gonna focus on the one about how, as a scientist, can you think about having agency in this, in addressing the institutional question that I've raised, which is a great question, and I want you all to feel like you have agency. But it's something I've thought about a lot, and I think one way to think about it as an early career scientist is look for places that are doing science in a way that you think is institutionally interesting and addresses the kind of complexities of these political scientific interactions. So I gave a couple of examples. Everyone will have, wherever you're working, there'll be many different institutions using science in different ways to solve different kinds of problems. So one can choose either in terms of where to try to focus one's career efforts on working in institutions that you think are successfully dealing with this kind of post-normal context. If you're a writer, you can write I mean, one of the problems I think is that we actually don't, when we talk about science, we still talk about it in terms of the hero genius scientist making the serendipitous discovery that changes the world, even though we know that's not really how it happens. So another thing that one can do is tell different stories about how science works. Tell it as this kind of contested, often politically difficult, highly uncertain enterprise. And so we can talk about it differently. That gives us agency. We can choose to work in places that we think are acting effectively in the world. That gives us agency. So there are lots of ways to intervene. You can even engage in policy development around creating new sorts of institutions that do things in different ways. So I think there's lots of opportunities, which isn't to say that it's easy, which is one reason why most scientists still do what they do, which is go into the laboratory and be a scientist. But if you're interested in this stuff, I think there's a world of opportunity out there, and it maybe is even harder than science itself.
Can I add something to that? I mean, yeah, okay. I also think that actually as an individual scientist, a lot of what you do is under your control. I mean, that's one of the wonderful things of being a scientist. And so I have yet to hear of anyone who has had a career disadvantage because they improved their practices. I mean, if you become transparent, if you have a procedure in place that makes your science reproducible, that can only be to your advantage. And up to a point, at least, that doesn't take a huge cultural shift around you. I think to some extent you can do that on your own, even as a junior researcher. And if 2 or 3 people in a school do that, then you'll change the culture there as well. Now, maybe I'm being a little too optimistic with that, but I certainly wouldn't rule out that possibility. It depends on your field, of course, but certainly in my field, it's up to the individual to choose whatever practices they follow.
Well, that's actually a perfect opportunity for me to capture the screen very briefly and to show you some things that the Trust in Science Working Group has been doing in the last couple of months. So we started also with this question about what young scientists can and should do. And we had the starting point that at least in some areas there is a challenge for trust in science, but we also realized very quickly in our discussions that there are also challenges for trustworthiness in the sense that as young scientists, sometimes the incentives are just stronger to p-hack or to publish the smallest publishable unit or to do all these weird things that the incentive structures in science might lead you to doing. But also there's so much at stake for young scientists because we all want to make meaningful contributions to society. None of us started out saying when they were 12 or so, I want to get the greatest grant or I want to chase my age index or anything like that. There is a lot of interest among younger scientists in communicating with broader audiences. Many of us are in social media. And there's also a lot of at stake for us in the sense that the long-term social contract between science and society needs to hold, otherwise we will not be funded in the long term. And what we realized is that there is actually a lot of research out there on science ethics, sociology of science, history of science. And there's also a lot of practical experience that people have collected about how best to communicate. But lots of young researchers don't know about this. So what we thought we'd do, and we're in the middle of doing it, is to create a project together with partners. We got funding from the VW Foundation. We partnered up with the NAVIC, which is the National Science Communication Institute, and created this project CISO. And I first thought I would only be able to show you some stills of some of the animated videos that we've started to do. We will also have videos with a moderator, but because of COVID and because of Brexit and visa troubles, we have not yet been able to produce these videos. We have a wonderful young moderator, a science communicator herself, who will talk about these issues. But fortunately, our filmmaker, Christine Rabe, I think she's also here today, managed to get 3 of the animated videos done. So they are up on the website. They are hereby officially launched. They are sort of a random mixture of topics because they are the ones that happen to be animated videos, and the ones with the moderator will still need to be produced, hopefully in September. And the aim is, in a way, more to raise questions and to point people to resources than to provide answers, because these are all things that need to be discussed on an ongoing basis. The situation is different in different countries, and we very much hope that you'll have a look at these, maybe share them, discuss them with your colleagues, take them as an opportunity to raise these issues and to contribute to what was also in the last question, namely to improve our scientific practices in our scientific institutions. But to end with, what I'd like to do is to ask our 3 panelists for one last word of advice for young scientists. And because we have the corona crisis and the issue of trust in science, or the relation between science and society, is currently most urgent in a way. Well, climate change is always very urgent, but the vaccine issue is in a way more in the headlines. So maybe each of us could tell you briefly what we as young scientists should do, in your opinion, to help build trust in vaccines. And maybe we can just go in the same order as in the beginning, and I hand over to Marcia.
Okay, I talk about science everywhere. I know that may be just a drop, but it's a drop that makes me feel that I'm contributing to the thing. So if I'm traveling or talk to the person next door, and one thing I realize, because I just look like them, makes all the difference. Because I don't look like the image they have of a scientist, you know, with the white jacket and the hair like that. They listen to me, and I listen to them, and that makes a conversation about the thing I'm passionate about at the science. So talking about science is good for me, and I'm sure this person, when think about what the scientists are saying, we remember someone just like themselves, the person next door, that can tell one additional evidence, and that's built trust by empathy.
Thank you so much. Dan?
I think, Marcia, you ended up by saying build trust by empathy, and I think that's exactly right. The only thing I would add to that is I find it really helpful to examine my own sources of irrationality and belief. Almost all of us have constructed our view of the world by accepting things that people have told us or that we've read, not through our own personal experience or empirical testing of things. So, and everyone is subject to that. So our head is all filled with all sorts of beliefs. We have no reason to understand, no way to understand how we've completely constructed them. Everyone is like that. And once you realize it about yourself, it helps you be more accepting of why other people might believe things that you think are silly or gibberish or not constructive. And I think that act of empathy then helps you interact with them and be a more kind of compelling interlocutor in these kinds of difficult discussions. So I would just completely agree with Marcia's point about the act of empathy.
Thank you. Stephan?
Yeah, great. I agree with that. The only thing I would add to that are 2 things. Number 1, practice audience segmentation. That is, consider who you're talking to, because different audiences will be receptive to different messages. A personal conversation over a cup of coffee or something stronger is very different from giving a public presentation of your results or being interviewed on the radio. So, you know, there's lots of different things that apply in different contexts. And the second thing I would add is that when you communicate your science, what I try to do is to be, I do my best, and maybe I'm failing all the time, who knows, but I do my best trying to be calibrated in what I say with the strength of the evidence on which I hope my belief is based. And that cuts both ways. That means I don't want to exaggerate anything in terms of how certain I am about the knowledge, but equally, I'm also not going to retreat and say, oh yeah, you know, climate change is uncertain. Well, actually, it's not. The basic physics of climate change are not uncertain. The effectiveness and safety of vaccinations is not uncertain. You know, we've got 100 years of history to back that up. So calibration is very important, and being sensitive to who you talk to.
Well, thank you so much, everyone. This concludes our session. I want to thank our speakers once more for their great input. I would also like to thank the office that has made all of this possible in the background and done a lot of work. In half an hour, we have the last public session of today, which is about building trust through open science, something that came up at various points in the discussion. So hopefully see you there. And again, thank you so much. Keep communicating, keep talking about these issues. They will continue to be important for us. Thank you so much.